Welcome to a lesson with Dr. Powell. Let's look at this following limit. This looks rather nasty. However, this part right here actually has some nice bounding properties. Cosine itself, no matter what you plug in, is in between 1 and -1. Now, what about e to a negative? Now, it's for sure a negative, no matter what it is up here, e to the negative. What does that look like? Well, think of anything like 2 to a negative power. It's always going to be like 1 over 2 to that something. Now, in general, and if you think about this as being a positive power. All right. Now, if you think about 1 over 2 to the positive, I mean, we're really dealing with e, but just, let's just think about it. 1 over 2 to the positive. Think about, okay, what could happen? Now, if positive is big, this number is going to be very small. So, if it's close, the other thing is 2 to the, let's suppose if it's 0, so it gets close to 0, so it gets close to 0, then this guy right here is just a little bit bigger than 1, and the smallest it can be is actually 1. Meaning that the biggest this fraction actually can be is 1. In fact, if you looked at the graph of e to the negative x, it looks like this. But if you do absolute value, what it does is it actually outputs what you have over here for plugging in positive input over here actually becomes what you plug in over there on that side. So the graph of e to the negative x actually looks like this. So we're not really doing e to the negative absolute value of x like I'm explaining. That's what this graph is. However, we're plugging in things into this. And so we're still plugging in something into e to the negative absolute value of something. So, I mean, whatever we do, we're going to get some output value that we see here in this graph. So, which are bounded between 1 and 0. So this part is actually bounded between 1 and 0. Kind of a nice to have that bounding. Because now since you have the bounding of the different parts in there, let's see what that does. That means that whole piece is actually bounded below by -1 plus 0. So it's bounded below by -1. And it's bounded above by 1 plus 1. So it's bounded above by 2. So this whole thing in here, which means that the whole expression itself is, we'll just multiply everything by x minus 2. Well, you got to be careful. If you're going from the right side of 2, then you can freely multiply because then these will be positive and it'll preserve. So wait, x minus 2 times the whole expression. Okay, or that guy. So basically, maybe what I'll do is think of this part right here as being all of that. Okay, right in there. Okay, so when x minus 2 is positive, then this inequality is preserved right here because we multiplied by positive. But that's fine because because if x minus 2 happened to be negative, if we were dealing with a left-handed limit, then the inequalities would just be reversed, going the other way. So, but whatever the case may be, this whole expression is in between these guys right here. This is times -1. That's a times, okay, 2, all right, bounded between those. So think about this, as x goes to 2, this is just 0 times a number. Well, that's just 0. On this side, that's just 0, which means the middle part, whether or not you're this inequality or that inequality, goes to 0, which means this whole thing actually just goes to 0. That's because this was bounded very nicely. Now, the only problem that would arise is if this was actually some kind of infinite thing times 0. That's the only way you can counteract that and actually maybe get something else out, which you wouldn't know what it is because there's a million and one ways or more, infinite number of ways of getting a 0 type thing times an infinity type thing, and who knows what that'll be. However, if we have 0 times a number, we for sure know what that is. That's just a number. Or it's not just a number, it's a 0. That's what I meant to say. It's just 0. 0 times a number, but that's not infinite. It's just simply 0. Thanks for watching.